Good afternoon. This is Eastern Washington University, Department of Engineering and Design. Here in the materials lab today, we are going to be doing a 3-point Flexural test on a piece of thermoplastic composite, as shown here. This test is based off of an Aerospace Standard Test Method, or ASTM method for short, numbered ASTM D7264-15. It is a method used commonly in the aerospace and materials testing industries. Here we have our fixture and our sample on top of it. This sample needs to be measured, as does a part of this fixture, before you do any part of this test and calculate your results. Here you have a specimen or sample that's already been tested. You can see the breaking point right there. Here's a new sample. First thing we'll measure off of this sample are the width and the thickness. The width here and the thickness, like so. These dimensions you are going to need for your calculations later on. Use a caliper, such as the one shown, to make these measurements. The next thing you need to take note of is the loading span, the spacing between this pin and this pin right here. On this fixture, there's different tick marks with numbers. These tick marks are in inches, and they do not represent the distance from this point to the middle right there. No, this 4, as shown right there, as you can see, represents that this pin and this pin are exactly 4 inches apart, as long as this edge right here is at that tick mark number 4, and that this edge is at the tick mark number 4 as well. Make sure that that loading span is correctly set up and that you get that number off of the fixture. Come over here to your Excel sheet, or you might have a notebook, whatever Dr. Hossain prefers. You can see these are the different specimens that have been tested. Right now we're on specimen number 10. Here, there is the measurements for the width and the measurements for the thickness. Down here are the average measurements. These average measurements are the width and thickness numbers or values you're going to plug into your data. Back up to the top. Take note of what the loading span is in inches, 4 in this case. Always be unit consistent. Coming back over to the machine, we have our sample. Put it on like so. Make sure it's as centered as possible, as you want to make sure that you get real nice, good data. If it's off like this and it's not overlaying, this could slip off during the test and you'll ruin your results. So make sure it's as centered as possible, like so. And double check to make sure your fixture's all been, nice and secure in place. In this case, it's already been double checked, so we are good to go. Coming over here to this screen, clear your results from your last test. Press enter. Where it says number 7 is results, click on number 7. Number 3, or selection 3, will clear all the results. As you can see on the main screen, the graph is clean. The next step is to check the settings in which the machine is going to do the test. Press menu and go to option 1, speed. That is the primary setting we are concerned with today. Where it says speed 1, use speed at 0.25 inches per minute for this particular material. If you use a different kind of material other than the one shown here, you might consider changing this speed. That's going to be up to whoever's in charge of the test. In this case, Dr. Hossain. Press enter again to return to the main screen. Now, we want to make sure that this specimen here is in the right position and that this loading pin up here is right on the edge of touching that specimen before we begin the test. So, click this button here to have jog on. Come back over here, and by pressing this down button, you can move the head down until it just touches the specimen. Just like so. Maybe a little bit up. Perfect. So right about there is where you want this thing. Now you're ready to begin your test. 0 your force and 0 your extension. See how they read 0? This is good. Press this button again, take the jog off to where this says stop, just above the 0.75 inch call out. Press the test button, telling the machine you're ready to test, and press the down arrow. The machine is now testing the specimen. Load is being applied from this pin. These two are remaining motionless. At this time, it's a good time to mention that everyone in the group should be wearing safety goggles. If you are not wearing safety goggles, please stand at a safe distance away from the machine, as we don't want anybody getting hurt in the eye from shattering splinters or unnecessary explosions or something like that. So, making sure everyone is wearing personal protective equipment is very important. You can see it's now really starting to bend. As you can see on the graph, it's going to jog down. That's just the scale the graph is in at this particular moment in time. When you print your graph, it will show a nice continuous line to show you a nice slope and a good line that you can get all of your data points off of for calculations. There's your force going up and there's your extension. Pretty soon you're going to hear some crackling. Those are the fibers of this composite specimen breaking. When you hear a big crack, that means this specimen has broken, and you can stop the test and reset it. That big crack is what we were listening for. As you can see, the specimen has broken. It no longer has the strength it originally had. What I did as soon as I heard that break is I pressed the stop button here. This is your eventual graph where it shows from start to finish. That's the point right up in there where it broke. Press print to print your graph. Now, always make sure you have proper paper in here. There's your paper. Now print your results. After the results print, Dr. Hossain will give you further instruction on how he wants you to analyze the data. I hope you enjoyed this video, and go Eagles!